Today we're going to look at the solar system, and specifically we're going to look at the Earth's rotation and revolution, as well as the phases of the moon. So when we're looking at rotation, we say that rotation means spinning on a fixed point. So kind of like a basketball spinning on a player's finger or a tire spinning on a bike. It just kind of rotates around and around and around. So if you look at the wheel, when I spin the wheel is rotating around. It is not moving, it is simply just spinning around. So the Earth spins just like a wheel on a fixed point. And the fixed point is called the axis. And the axis is kind of like a stick that goes all the way through the Earth, through the bottom, and through the top. And of course, this gives us our South Pole and our North Pole. You can also think about this kind of like a stick when you put it through a marshmallow and you go to roast it on a campfire. You want to keep turning the marshmallow around and rotating the marshmallow so that one part of the marshmallow doesn't just sit on the flame the entire time and burn, and the other side gets cold. So what you want to do is you want to spin that around. You want to rotate that around. And we do a 360 every 24 hours, which is equal to a day. Now, I also want you to notice that the Earth is tilted a little bit. Now, that's going to be very important in the next slide, but I want you to notice that the Earth, it's kind of like leaning forward a little bit. If the axis was straight, it would actually kind of look like this. And I know this is kind of what you sometimes picture the Earth like, because when you look on maps, or sometimes if you look at actual photos of the Earth, the astronauts take the image so that the Earth is straight up and down, but it's actually tilted so that, like I say, it's kind of leaning towards one side. So now we're going to look at the process of revolution. Now, revolution kind of means like circling around something. So think of like a merry-go-round that you might see at a circus or at a fair. So the Earth revolves around the sun. Now, I have chosen to use a light bulb to represent the sun because we know that a light bulb directs light from all directions, not just straight out this way, but if you were looking at it, there would be light coming toward you as well, and there would also be light going behind you, behind the light bulb as well. So I just want to make sure that I use something that you could picture. So the Earth orbits the sun in a counterclockwise direction, and you'll also notice that the Earth is not going around in a circle around the sun. It's actually going around in what we call an ellipse, which is kind of like an egg shape. Now that's really important because the Earth having an egg-shaped or an ellipse-shaped orbit is what gives us our 4 seasons. If the Earth went in a circular orbit around the sun, we would just have 1 season. But as you can see, as it's going around, at certain points, it is further away from the sun. And as it comes around its revolution, you'll notice that it is getting closer to the sun. Now, we can use a line to measure that as well. So I'm going to use a red line to show the distance between the sun and the Earth. Like that. I think this needs to come a little bit longer. There we go. And now I'm going to continue going around the sun with the Earth, and I'm going to try and see if I can find the furthest distance from the sun. That looks about right, so I'm going to draw a line to represent the distance from the Earth to the sun here. Okay, so let me just move the Earth out of the way for a second. Alright, I'll park the Earth over here. So now because we have these two lines, we can actually show that yes, indeed, the Earth is closer to the sun here than it is up right here, because we can actually move and manipulate these lines, and we can see that the blue line and the red line are different sizes, and the blue line would represent winter and the red line would represent summer. So if the Earth is traveling from summer to winter along its orbit, it's going to travel along this line, and halfway between summer and winter we are going to find the month of fall or autumn. And of course, after autumn we end up with winter. And now we are currently on this side of our orbit, thank goodness. And eventually we are going to end up with spring. So just like a car going around a race, the Earth continues around this sort of track, and it keeps revolving around the sun, going around and around and around. And we make this trip every 365.25 days, which is why every 4 years in February we have a leap year. So this year in February 2020 had 29 days. That is because we need to make up for that 0.25 or 1 quarter. So every 4 quarters equals a whole extra day. So we stick it onto February, and that way our seasons do not change. If we didn't have leap years every 4 years, then you might be going to school when it's really hot out and having your summer vacation when it is really cold out. So thank goodness we have the leap year every 4 years to make up for that 0.25 of a day. So again, just to review, rotation means spinning on an axis, and revolution means circling or going around something. Okay, so now we are going to look at the different phases of the moon. So as the Earth is revolving around the sun, our moon is also revolving around the Earth. So our sun is going around, or Earth, sorry, is going around our sun, and our moon is going around the Earth. Now the moon doesn't rotate, so it doesn't spin. So we always see the same side of the moon, always facing the Earth at all times. And then we also have the far side of the moon, also known as the dark side of the moon, on the other side. It's kind of like if you were facing a campfire and you never ever spun around, the front part of you would always stay really warm, and the back of you would stay really cold. So now you might be wondering, well, why in the world does the moon look different on different nights? Well, it's because the Earth kind of gets in the way between the sun and the moon. So there's sometimes when the Earth is sitting right in front of the moon, just like that, and none of the sun's light is able to get to the moon. There are some times when the Earth is just blocking off a part of the moon. So you get to see that little, we call it a crescent moon, up in the sky. There are other times where the Earth is blocking about half of the moon in the sky. There's other times when the Earth is actually behind the moon, so you can't see, you could see a bright reflection of the moon, so the Earth is not blocking any of the moon, so you can see the whole thing. And then of course you can see half of the moon again here, and sometimes it's only blocking just a tiny bit of the sun's light from hitting the moon, so you see more of it, and then again it comes all the way around here. And that takes about a month to go from seeing no moon to seeing a full moon back to no moon again. So with these different phases of the moon, we call this one here at the top, we call it the new moon, because it's just freshly there and you can barely see any of the outline. There's like a faint bit there, but you can't really see much of the moon. Now over right here you can see a little bit of the moon, and we actually say that you can see about 1/4 of the moon, because about 1/4 of the moon is exposed to the sun's light. Then as we come down this side, well, this one looks fairly easy to see. You can see about 1/2 of the moon. So 1/2 of the moon is completely lit up, or you could say 2/4 is completely lit up. In fact, I'm going to change that to 2/4 because we've been doing equivalent fractions in math. So I'm going to keep it there. Now, as you travel down here, well, we can see all of the moon. So we call this the full moon, because again, if we're talking about quarters, you can see 4 out of 4 quarters of the moon, so you can see the full thing. And then as we come across on here, you end up seeing half a moon again, or you see 2/4 of a moon, because again, this is equal to the same amount. Then if you come over here, you can see that you can see a lot more of the moon. You can actually see 3/4 of the moon. And then when we get back here, we have a new moon again. And I guess we could even go so far as to say that when it's over on this side, you could see 0 out of 4 pieces of the moon, because it's completely dark. You can barely see the moon in the sky during a new moon. I hope this video was helpful in explaining the difference between rotation and revolution, as well as explaining why we have different phases of the moon.